what are you doing?
Taping you.
You're taping me?
I'm recording you.
Okay.
Remember
Oh, I can't say anything. Let's say, did you start recording?
Yep.
Say good things. What's that? I didn't say it. In my Chem 2 class also, they record the lectures, and students usually see that. So, okay. Do you have any questions? Any doubts? Any questions? Okay. Let's continue with chapter 5. You actually, this is a pretty important thing. We are going to start from a very important topic. Writing Lewis structures. Writing Lewis structures. For molecules and polyatomic ions. Writing Lewis structures for molecules and polyatomic ions. Lewis structures are also called electron dot structures, like the dots we have been doing for elements. We'll be doing now for the molecules. What I usually recommend is you need a page, this page full, to write the rules. Okay? But we do one rule at a time. Once we go one rule, then we start doing some examples. Do not do more than 3 or 4 examples on one page. And we're going to do 12 examples today. You guys with me on this? So one page will be just rules. The other we'll be doing examples 1, 2, 3. If you write bigger, then do only 3. If you write smaller, do 4. Sounds good? Right on step number 1. Step number 1. Drawing skeletal structure. Drawing skeletal structure of the molecule. In step 1A. Step 1A. This is important. The least electronegative atom. The least electronegative atom is the central atom. Is the central atom. Excluding hydrogen. Excluding hydrogen. And you have to go with this particular chart. This is what you'll be using. Not the true values, you have to go with this. You guys remember this? Okay. B, 1B. All the atoms all the atoms in the skeletal structure must be connected by single covalent bonds. Single covalent bonds. C, steps 1C. Hydrogen must be at the end of the molecule. Hydrogen must be at the end of the molecule. And will never have an octet. Underline the term never. Will never have an octet. D. In the skeletal structure, octet, and valency, something new term here, valency. May or may not be satisfied. May or may not be satisfied. Under D, what's that? Valency is the number of bonds. Valency is the number of bonds an atom usually forms. Underline the term, usually. Let's think about it for a second here. Nitrogen has how many dots around it? 5. How many more it needs? 3. So how many bonds it will form? 3. Am I right? So nitrogen usually likes to form 3 bonds. Carbon has how many dots? 4. So how many bonds? 4. Oxygen?
6.
It has 6 dots, so it will form 2 bonds. Same with fluorine, 7 dots, it needs 1 for 1 bond. That how many bonds they form, they are called valency, monovalency, divalency, trivalency, tetravalency. Sounds good? Let's make a chart here. This is second. Carbon 4, nitrogen 3, oxygen 2. Okay. X means halogens 1. Fluorine and hydrogen are always 1. Always, no exceptions. Sounds good? So in the skeletal structure, you may not have these satisfied. It's okay. So X stands for halogens. What is the step B I gave you? 1B?
All the atomic cells reduction must be connected by single covalent bonds.
Okay. Should be connected by single covalent bonds. In the parenthesis, write no exceptions. No exceptions. This is mainly for high school students. you have the habit of writing the double bond, triple bond right away. You can't do that. It's not wrong, that's not the best way to do it. You guys got it? This is step 1. Okay? Step 2, 3, and so on are easier. You know, this is the main step. Okay? So now leave this space. Now we'll start with examples. Again, I'm going to repeat that do not do more than 3 or 4 in a page. Sounds good? Okay. Start with example number 1. Everybody get your periodic tables, please. And I want you to put numbers so we can follow for everybody the same thing. We'll start with 3 right now and we'll go. So if you can, everybody can stop writing, listen up, have your periodic tables. Remember, this is any students who are taking organic and biochem or any other chemistry from here onward. This is huge. Okay? With that being said, I want to kind of talk to you guys about this. How many of you are going to take summer classes here at Western Iowa Tech? 1, 2, 3. Raise your hands, please. Okay. Have you signed up for classes?
Not yet.
Okay. The registration is open. Advising week is March 11th. I highly recommend you meet your advisors and start planning the courses. Summer should not be just for tanning, okay, or whatever. But you should take at least one course and get invested. Anybody taking any chemistry here from here onwards after this class? Organic and biochem or Chem 1? Yeah, Katie, which class?
Organic.
That's next spring.
Mm.
Okay. Dude, I've forgotten everything, by the way.
Yeah, I know.
Chem 1? Fall or summer? I don't know. Anybody else? Yeah,
Chem 1.
summer or fall?
Summer.
Okay, so you can sign up. The registration is open. Yeah,
Fine. Chem 1.
but summer or fall?
Saturday.
Okay. You guys have to start planning, okay? Meet your advisors. You should select the courses, making sure you know the end result, how it's going to look like. You guys make sense? Have a nice game plan to reach your end point, okay? So, start taking, signing up for courses, even for fall, you can sign up now. Okay, so you don't have to wait. Okay. Let's get the periodic table. Let's follow the rules. Let's start with SO2. Please, everybody, you don't have to write anything. You just have to listen, understand. Is there any hydrogen here? No. What is the least electronegative atom?
Sulfur.
You have O and S, right? So which one? Sulfur. Does anyone has any questions on that? Okay. That's the first step. It looks easy. This is where people fail. If you miss this step, you're screwed. Okay. Let's go to this one. We have a hydrogen here. So you always exclude hydrogen. You guys can stop writing. Everybody stop writing. Listen up, listen up. Forget hydrogen. So you have carbon and nitrogen, which is the least. Here, exclude hydrogens. Are we clear on this? Any questions? Okay. Once you know this, and this is the place you're going to learn. You cannot go home and learn by yourself. That's not going to happen. It's here on nowhere. Okay. Now, all bonds are connected by single covalent bonds. How many sulfur is connected to? 2 O's. Okay? Where is sulfur present in? What group?
Let's go guys.
So how many bonds it likes to form? Two. Okay. Carbon. Carbon likes to form how many bonds? Four. But right now it is connected to hydrogen and, am I right? Is the valency satisfied here? No, it's okay. You guys with me on this? It's okay not to be satisfied. We'll take care of that later. Now, carbon is connected to three, let's connect it to three hydrogens. 1, 2, 3. Okay? Connect the fourth one to O and H. This H. Is there any other combination? How about here? It's the same thing, right? It's not how it is drawn, it is how it is connected. You guys with me on this? Now carbon has how many bonds around it? 1, 2, 3, 4. Here the bonds are satisfied. One bond is how many electrons? 2. 2, 4, 6, 8. So carbon here has an octet completely full, valency full. Here it is not. It's okay. You guys with me on this? The reason I have put the central atom in different color is that's of highest importance. You guys make sense? You cannot afford to make a mistake there. Go and write on this.
When it's not fulfilled though, the octet, does that mess with its stability?
So this is just the first step.
Yeah.
Skeletal structure. So it's like, I tell this is not a great example, kind of logic, but it works. It's like we're getting ready for the turkey day, Thanksgiving day. We just bought the turkey. Okay. This is the raw, cold turkey. Okay. You have to do the fillings, butter up, beer, turkey, whatever turkey you want to do. So this turkey is here now. So by the end, it should be a nice turkey with all octets and it kind of works, right? It kind of gives an idea. Okay. So please don't do more than 3 or 4. Okay, that's what I'm trying to. Because otherwise it will be a lot. You'll be writing a lot of things on that. Let's do example 4, CH2O. Example 5, NO2F. Example 6, H2O. 7, 3. Please write numbers so we can follow it correctly. 4, 5, 6, 7. Write a skeletal structure. 4, 5, 6, 7. It's okay if you make mistakes. You can use your imagination here, okay? What cannot be made mistake is the central atom. How many of you applied for scholarships this year for West Nile Tech? 1, 2, 3, 4. Have you asked your people for recommendation letters? Have they done it? Make sure. Okay. Are we getting this? CNON is a central atom. Now, so hydrogen, oxygen. Again, it does not matter how you draw it. It matters how it is connected. Anybody has drawn anything else? No? How many have you drawn like this? How many have no clue?
I'm just kidding, I'm not that bad.
That's a good one. I was a little worried already. Is this wrong? Tell me what is wrong. It can be white. Have I made any mistake in my rules by writing this?
Just the center atom.
Not really sure, right? Which central atom it is. Okay, agree to that. And that actually creates a mess in the later on. But we are not sure, so it's at least it's okay so far. So you guys go ahead and write down and put a question mark. And we'll see why this is not a correct structure. Okay. This next one. NO2F. H2O. NH3. How many got all four what we have drawn? Raise your hands. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.
Does it matter if the O's on the top and the F?
It does not matter how you draw it. You can write H here like this, take it out, put it here. It's not how you draw it, it's how it is connected. Go ahead and finish 8 through 12. The plus and the minus charge will not make any difference to your skeletal structure.